everyone, myself Biplav Bhattacharya and I welcome you all in this course Introduction to Sequence Stratigraphy. So far we have discussed about the different fundamental concepts and definitions of sequence and related terms, and also we have tried to learn about the cyclicities, about different types of stratigraphy. Now from today's class I will take you to a different aspect which is more related to sedimentological aspect and which is also considered as the fundamental unit, fundamental idea before we move on to sequence stratigraphy. So, today we will discuss about the concept of phases, and when I am meaning phases, I want to mean sedimentary phases. So, in this class and also in the next class, we will continue our discussion on sedimentary phases. So, first we have to understand that what is a sedimentary phases. We all know that sediments, they are derived from the source areas, whether that is clastic sediments or whether they are chemical sediments. Chemical sediments are derived through some chemical process, they are carried in solution, dissolved in water, and then they are precipitated. Whereas in case of clastic sediments, they are all derived through erosional process, weathering and erosions, and from there they are transported physically, mechanically, and finally they are deposited in some areas which are commonly the depressed areas, which we commonly call as the basins. And during this entire process of production, transportation to deposition, several processes are involved, and those processes are characterized or distinct from each other in terms of their mode of transportation, mode of carrying the sediments, mode of precipitation or deposition of the sediments, and in terms of their energy condition. When this energy condition they varies, it will affect the type of sediment which is being transported or which is being deposited. If we just consider the case of a clastic sedimentary system, where under certain energy condition some sediments are derived and those sediments are finally getting deposited. So, definitely for this process energy condition is required. So, for a particular energy condition, what we can expect is a particular type of grains will be collected or a particular range of grain sizes will be collected, will be transported by that particular flow. So, if the grain size is much coarser, that particular flow having that energy condition will not be able to carry those sediments. Just think of in a very simple example that if I give you a 5 kg load, so you can carry it very easily as per your energy condition, your body strength. But instead of 5 kg, if I give you a bag of 90 kg, you will not be able to carry that one. So, it is about how much is the ability of the flow, ability of that particular agent, and that ability is counted or represented in terms of the energy of that particular flow. So, for carrying coarser sediments, we require higher energy. For carrying finer sediments, we require lower energy. On the other hand, maybe when a flow is starting, at that particular time, it may have very high energy. So, with high energy, it can carry all the types of sediments, including coarser grain sediments and finer grain sediments. As it moves forward and the energy condition gradually decreases, the first thing that will be done is the coarser grains will get deposited, and as it will move forward, the grains relatively finer with respect to the first lot will get deposited and the rest finer materials will be carried forward. And gradually, progressively, as the energy condition will decrease, relatively finer grains will get deposited and further finer grains will be carried forward. So, in this way the transportation will go on, in this way the transportation process will continue, and the products will vary depending on the amount of transportation and the energy condition which is varying with this amount of transportation. So, depending on this variation in the energy condition, depending on the condition of the flow or the process, we can get different products in terms of the sediment deposit. So, it can vary from type of sediments which are coming up. So, kind of aggradation or erosion going on in the source area, how much erosion is going on, what kind of erosion is going on, and definitely what kind of rocks are present in the source area. that will control that what kind of sediments are produced at the source area. If the source area is a granite body, granite rock bodies are there, gneissic rock bodies are there, we can expect lot of quartz to be derived and transported and getting deposited. So, nature of sediments, what kind of sediment will be produced and what kind of sediment will be finally deposited depends on what kind of materials, rocks are present in the source area and what kind of erosions are going on. Similarly, how much balance is shifting in terms of the energy flux and the sediment supply. If you have a very high energy flux, lot of sediments will be supplied, lot of sediment will be carried forward and will be distributed along its path. Whereas, if the energy condition is low, many of the sediments will not be carried at all. They will left behind and only a small fraction of the sediments will be carried forward, mostly the finer grain sediments. The conditions control that what will be the final product. And when I am talking about the conditions, it means the condition of the flow or condition of the depositional system. A depositional system is controlled by several processes. When I am talking about a fluvial depositional system, there a channel is there and through that channel water is flowing, and that water flowing having different dynamics, different conditions at different parts of that channel, which results in erosion in certain portions, deposition in other portions, which results in a fluctuation in the water level, and that can cause flooding events. And due to that flooding, we can get other type of deposits in other portions of that particular depositional system. So, as the energy condition is changing, as the controls are changing, the resultant products are also getting changed, and that is the key for understanding the concept of facies. So, as per definition, facies is a rock body, basically a sedimentary rock body, which have certain characteristic aspect, appearance and properties, and that reflects the conditions of its origin, especially as differentiating the unit from adjacent or associated units. This is how a sedimentary facies is defined. So, what is the meaning of this particular statement? It means that facies is a rock body having any dimension, and that rock body has certain properties, characteristic properties in terms of different aspects. For example, it can have a distinct lithological property, it can have a distinct mineralogical property, it can have a distinct chemical property, it can have a distinct textural property, it can have a distinct primary structural property, it can have a distinct biological property in terms of fossil content, trace fossil content, and all these properties together makes this particular rock body very much distinct with respect to all other adjacent rock bodies which are lying above or below or lying in the side by areas. And when you combine these characteristic properties together of that particular facies, they collectively indicate or point to a particular process under which this sedimentary facies is formed or this particular sedimentary facies is deposited. Just we can take one more example over here. Say a sandstone. A sandstone can form in different conditions, but if a sandstone is a planar tabular cross-bedded sandstone, then commonly we can understand it is forming under an unidirectional current flow. Now, that unidirectional current flow can occur in several environments. For example, in a river channel, for example, in a wind flow, for example, in a tidal channel during flood tidal current or ebb tidal current. It can form under rip current in shore area, it can form in the turbidites. So, there are many possibilities where this kind of planar tabular cross-bedded sandstone may form. They can form in a deltaic condition, they can form in an estuarine condition. So, whenever I am getting a sandstone, maybe more precisely I can give you example like a medium grained sandstone. So, texturally I am defining it, lithologically it is a sandstone, texturally it is a medium grained, structurally it is a planar tabular cross stratified sandstone. So, it is becoming very distinct, and together all these properties will point to a particular process. So, then I can call this one as a sedimentary facies. The original definition of facies was given by Walker in 1992, which is followed widely, which is a very popular definition, which says that a particular combination of lithology, structural and textural attributes of a rock that define features different from other rock bodies. Defining facies from one area does not point to a particular sedimentary environment. What it points to? It points to a particular depositional process going on within a particular depositional environment. As the example that I have just given to you, that whenever we are getting one facies, for example, that medium grained planar tabular cross stratified sandstone. So, it can form in different environments. It can form in shore face, it can form in tidal flat, tidal bar, it can form in estuary, it can form in delta, it can form in point bar, river point bar. So, just by looking at that particular sandstone, a medium grained planar tabular cross stratified sandstone, I cannot interpret or conclude about a depositional environment. What I can conclude, what I can interpret is the process by which it was deposited. So, there I can interpret that this particular sandstone, this medium grained planar tabular cross braided sandstone was deposited through an unidirectional current which was having say moderate energy condition. So, looking at one particular facies, we can interpret about the process. We cannot interpret about the depositional environment. So, facies are controlled by sedimentary processes that operate in particular areas of any depositional environment. Hence, a facies actually interprets syn depositional processes. This is very important. Looking at a facies, identifying a facies and its interpretation gives us idea about the syn depositional processes going on in that particular basin. So, a very common term is facies analysis, where we try to define or identify different facies within a particular area, and based on those facies we try to interpret the depositional environment. So, there is a very common misconception. Many people believe that whenever we are looking at a facies, it will give us idea about the sedimentary environment. Absolutely not. A sedimentary facies can give us idea about the process within a sedimentary environment, and to get idea about the depositional environment, the entire environment, we have to look at all the processes going on in that particular depositional environment in 3 dimension. So, there comes the concept of depositional system, and another concept which is intermittent between facies and depositional system. That concept is facies association. So, we will discuss about facies association later on. Facies analysis, which actually incorporates all these processes, like looking at a rock, identifying a facies from that rock body, and in the same way identifying several other facies from that particular area, and then combining them together to get understanding of the distribution of different processes across space and time, and from there understanding the overall depositional environment. This entire process, this entire practice comes under the broad category of facies analysis. So, facies analysis is a fundamental sedimentological method of characterizing bodies of rocks with unique lithological, physical and biological attributes related to all adjacent deposits. And this practice leads us to interpret about the depositional environment, not a single facies, but facies analysis altogether, where we combine all the facies types present in that particular area. So, to carry out facies analysis, to identify facies, the best way is to look at the outcrop sections, because in the outcrop sections we can straightway reach to the rock, we can observe the properties of the rock in terms of its texture, in terms of primary structures, in terms of biological parameters, nature of contacts, overlying and underlying rock bodies, their properties and lateral distribution. So, when we look at all these parameters together, which is possible in outcrops, we get a wholesome picture to define a facies. So, identifying or defining a facies is best possible from outcrops. However, in absence of the outcrops, what we can do is we can look at the core samples from well logs. Cores are collected, and from there again we can get idea about the lithology, we can get idea about the texture, we can get idea about the contact relations to some extent, we can get idea about the primary structure to some extent, and that can help us in identification of facies types. And many times we can reach to the modern environments where we can look at the present day conditions, present day processes and how they are depositing the sediments. For example, in a river system, we can go to a river system and there we can observe that how a point bar is forming and what are the different sedimentary units occurring within a point bar system. So, what are the facies types that occur within a point bar system? We can go to a tidal flat and there we can see that in different parts of the tidal flat, what are the different facies are distributed, they are deposited under different processes going on the tidal flat. So, for carrying out facies analysis, we have to be very much careful in terms of identifying the basic properties, certain aspects which will help us to distinguish that rock body, to separate out from all other adjacent rock bodies temporally and spatially. A very important concept associated with facies is the Walther's law of correlation. So, as per this particular law, the facies that occur in conformable vertical successions of strata can also appear in laterally adjacent environments. In reverse world, it is also presented as whatever environments we are looking at today. If I look at today, we have the river systems. Those river systems are debouching into a marine basin through the coastal area, where maybe a delta is forming, maybe an estuary is forming, and then from that coastal area it gradually goes down to the deeper marine part. And all these environments are occurring today, if I think today as the timeline. So, today all these environmental conditions, environmental systems are occurring and they are producing sediments, depositing sediments as per their own energy conditions, as per the processes characteristic of that particular depositional environment. So, a river which is coming near to the ocean is depositing its own characteristic sediment. So, we can define facies types from that river. It is forming an estuary at the coastline. So, we will get some characteristic facies types of that estuary system, and then we can have the shore environment, self environment, followed by the deep marine part. Everywhere we get characteristic sediments getting deposited today as per the dominant energy condition and the dominant process going on in that particular area. So, definitely in the self area we may expect deposition of very fine mud, maybe the pelagic mud, whereas if you go to the deeper marine part, maybe a turbidity current is going on and sand is getting deposited over there. When you look into the estuary part, there may be a sand bar is forming under tidal current system. So, everywhere we are getting different types of deposits characteristic of that particular depositional condition and the process, and all of them are occurring today in one time plane and they are occurring laterally one after another. If tomorrow the conditions changes, they starts shifting. As the condition will change, these depositional environments will try to shift their positions, and when this kind of shifts will occur, one deposit characteristic of one environment will come over another one. And in geological history, what we see is vertical accumulation of this kind of occurrences of facies succession one after another in vertical succession. So, in time planes they used to occur in lateral conditions, laterally distributed environments, but with time, as we go across the time, there they appear in vertical successions. This principle, which is a very fundamental principle for correlation of facies and also a very fundamental principle used in sequence stratigraphy, used in facies analysis, is called as Walther's law of correlation of facies. So, Middleton in 1973 defined this Walther's law as, in a conformable succession, the only facies that can occur together in vertical succession are those that can occur side by side in nature. The same principle was told by Possamentier and Allen in 1999 in different words, where they said that the same succession that is present vertically also is present horizontally. So, what is the actual implication of this Walther's law? So, it says that the facies contacts, they shift in such a way that the deposits of an adjacent environment may lie directly over those of a laterally related environment. This is a very important concept and we have to understand this very clearly, because this concept is one of the key concepts used in sequence stratigraphy, and later on also during our discussions we will refer to this concept very frequently. So, we can take one example over here. Say this is a marginal marine environment, this is the coastline, say this is some construction is over here. So, this is the coastline or coastal area or the land area, and at this present time today this is the water level. So, this is the mean sea level, this is the today's mean sea level condition. For this particular mean sea level condition, what we are having here, say for example, we can have this much of deposition of one particular facies, maybe within the shore face depositional condition. After that we may have the self depositional condition, after the self we may have the deep basinal sedimentary conditions, and each of them have different facies. Say for example, here the facies type is named as A, in this case the facies type is named as B, in this case the facies type is named as C. So, at this particular point of time, say this is time t0. So, at this t0 time we are getting different facies occurring side by side with respect to each other as the sedimentary environments are occurring side by side to each other. So, laterally adjacent. Now, if there is a change in the sea level or there is an subsidence over here of the basin is going down, or maybe the sea level is going up, or maybe the reverse. So, any kind of changeover in this scenario, in this condition, for example, if I take the sea level is changing. So, definitely what will happen now, this will be the depositional condition for C, area for C, the shore face area. The self area will come over here in this part. So, this will be the depositional area for B now, and then this part will be the depositional condition for A. If this continues further, similar kind of conditions of say rising of the sea level or subsidence of the substrate, what will happen? Sea level will further increase and we will get this deposition of C somewhere here, the deposition of B somewhere here, and A somewhere here. So, now if this continues for some geological time, what we will get now? If you make a log somewhere here in this part, we are getting C at the bottom like this, over that B is coming over and over that A is coming over in this particular area over here. If you make a log somewhere here in this part, you are getting B overlain by A. So, those facies types which were at one time getting deposited laterally with respect to each other in laterally adjacent environments are appearing in vertical succession in geological time, and this concept is Walther's law of correlation. So, this helps us to correlate the facies types. So, definitely this A and this A lithologically they are very much same. So, they are indicating same depositional condition, but across the time their positions has changed. So, they are cross cutting the time, because the condition for deposition of A over here and the condition for deposition of A over here are not exactly same as per their time of deposition. So, this contact is a time transgressive contact. So, this concept is one of the most fundamental concept used in sequence stratigraphy as also in stratigraphy. So, whenever we talk about these individual facies types, as I have mentioned earlier also, they commonly indicate a particular depositional process. So, looking at one particular facies, we cannot interpret about the entire depositional environment. What we require is we have to look at all the facies types occurring in that particular area, in that particular depositional environment. For doing that, what we try to do, what we commonly practice is, we try to group different types of facies together, which actually implies that we are grouping the processes which are responsible for the formation of those facies. And for that clubbing of these different facies together, the basic rule is we should look for genetically related facies types. So, those facies types which have a common genetic relation, common process, maybe within a major broad process there are certain variations, and those minor variations are resulting in different facies. So, all those facies types can be clubbed together to interpret about the major process. So, when we club together this kind of genetically related facies types, we call them as facies association. So, a facies association will indicate major processes within sedimentary environment, and in many cases they can even interpret about a major part of the environment if not the whole. So, facies association is a critical element for the reconstruction of paleodepositional environments. Such reconstructions are the key for interpretation of sequence stratigraphic surfaces and other sequence stratigraphic elements. So, we will continue our discussion in the next class, and there we will discuss about the detail of the facies association, this concept of facies association, and we will discuss about how these facies associations are defined and what are the implications, as well as we will try to look into the other aspects of facies and facies analysis. So, these are some references which you may follow for further reading. So, we have tried to understand in this class the concept of facies, what is the definition of facies and what is the practical use of facies, how we define practically a facies. So, the best way to define a facies is to go to the outcrop, look at the outcrop section, take sample and identify that. A facies indicates a particular depositional process, not the entire depositional environment. And also we have tried to understand one of the fundamental concept in stratigraphy, the Walther's law of correlation of facies, which says that those facies types which are appearing in vertical successions used to occur in laterally adjacent environments in the geological past. So, with this I will conclude this class, and we will continue this discussion in our next class, where we will discuss about other aspects of facies and facies analysis. Thank you everybody.